So this is an introduction to what we're going to be doing in Unit 11, and it's all about radicals. So the radical is just the square root symbol. It can have more than just a square root though. Like if you could see, sometimes there is a 3 square root, okay? So it's actually a radical, even though we almost always call it the square root sign. So if you want to just think of it as a square root sign, that's totally fine. All we're going to do in our class is square roots. We're not going to do cubed roots or anything like that. Okay, so our job is going to be to simplify radicals. What does that mean? That means there are no perfect square factors in the number under the radical, the square root sign. So a couple of terms here. Perfect squares. You all have this little list. Let me find it here. Of the perfect squares. So the right-hand side are what were called perfect squares. What that means is you take the square root and you get a whole number. Like if you typed in the square root of 10, you're going to get a really weird decimal because nothing times itself is 10. But along the right-hand side, if we look, we find 64. 8 times 8 is 64. So 64 is called a perfect square. When you take the square root, you get 8. So you're going to use the right-hand side are your perfect squares, and then the left-hand side is the square root of that number. So you have that, you'll get to keep that sheet all of the time. Factors means it goes into, can be divided by that number. All right, so what we do is that if we have, obviously you just get a single number. So if you look down at number 1, we have the square root of 18. What you're going to do is you're going to split that into 2 numbers. And then you can take the square root of them separately. So this is the square root of A times the square root of B. One of these 2 must be a perfect square. So either A or B. I'm always going to put it as A because we want our whole number to go on the outside. But it doesn't matter which one it really is. Okay, so we think of 18. We're going to go and we're going to look at our list. What number on this right-hand side goes into 18? Well, 9 goes into 18. So we are going to break 18 into 9 times 2, and then we put the square root signs around it. You have to put the square root signs. It's not just 18, it's the square root of it. So you have to keep the square root around each of those numbers. Now, the square root of 9 is 3. So square root of 18 simplified is 3 times the square root of 2. That's how we write it, 3 square root 2. That's how your answers are going to look today. So number 2 is the square root of 75. So again, you need to go and look at this list and find what number on the right-hand side goes into 75. Goes into means divide it. If you're not sure, start taking 75 divided by 4, divided by 9, so on and so forth. So if you're not sure, you need to just keep dividing until you find a number on this right-hand side that goes into it. Hopefully we know that 25 goes into 75. So 75 is 25 times 3 square root square root. The square root of 25 is just 5. So 5 square root of 3 is our final answer. Number 3 is a little tricky, okay? Don't write anything down yet, just watch. Some people think, well, I'm going to make this 18 and 10. Well, wait a second. If you look at your list, 18 and 10 are not over here, so that doesn't work. It has to be a number that goes into, or it has to be a perfect square that goes into those. So 18 and 10 doesn't work. Other people up here are like, well, 9 goes into 18, so 9 would go into 180, and it would be 9 times 20. Now, I'm going to keep going with this, and then I'm going to kind of explain a couple of things about this. All right, if you do 9 times 20, you're not wrong. But here's the problem. 20 also has a perfect square in it. So what you can do is you can then break down 20 right here, or you can start over. So there are 2 different ways to do it. You could just keep going to make sure your square root doesn't have a perfect square in it, or you can completely start over. One thing that you should know is this. If 9 goes in and 4 goes in, 9 times 4 is 36. So the fastest way to do this would make this 36 times 5. Okay, now if you don't want to do all that, that's fine. Look over here how I'm going to make this 4 times 5 square root square root. Here's where we have to be careful. This becomes a 3, this becomes a 2, and it's all multiplication. So our final answer is 6 square root of 5. So if you don't find the biggest perfect square right off the bat, that's okay. You can keep simplifying the other square root. Just make sure you multiply your outside numbers. If you don't like what I just did right here, then you need to make sure you find the biggest one. All right, so one hint I'll kind of give you is if you look at your list, since we have 180, I would start with like 81. Take 180 divided by 81, doesn't work. Divide by 64 doesn't work. 49 doesn't work, but 36 does. So you actually want to start with your bigger numbers and work your way down. All right, so the fastest way to do this would to make it 36 and 5, and that's how we get 6 square root of 5. So I just want you to realize there's more than one way to do these. The easiest way is to make sure you find the biggest perfect square that goes in. If not, then you can do it in a couple of different steps if you want. All right, number 4 is a little bit tricky. There are no perfect squares that go into 66. The only 2 things that go into 66 are 6 and 11. So if you can't find anything that goes in, then you just rewrite it. That's it. So that happens every once in a while. Okay, 294. I have no clue what goes into 294. So what I'm going to do is I'm going to look at my list, 294. I'm going to start with like 144. So 294 divided by 44 gives me divided by 144 gives me a weird decimal. So that's not it. Then I'm going to divide by 121. 294, I'm just doing this in my calculator. 294 divided by 121, another decimal. I know 100 doesn't go in. 294 divided by 81, more decimals. 294 divided by 64, still a decimal. 294 divided by 49 is 6. So 49 and 6. So sometimes it takes a while to go through that list and find your perfect square that goes in. That's totally fine. All right, 49 times 6. Square root, square root. Square root of 49 is 7. Square root is 6. There's your final answer. Okay, I'm going to do number 6 like I did number 3. So you can see a couple different ways to do this. So 48, right off the bat, I know that 4 goes into 48. Okay, it's 4 times 12. That one I know. Well, if I do that, here's the problem. 12 has another perfect square in it. So 12 is also 4 times 3. So I can have all that. It might be helpful to cross out that 12 then. So this 4 becomes a 2. This 4 becomes a 2. 2 times 2 is 4, square root of 3. So that's the long way to go about it, but it works. The other thing would be, as soon as you knew it was 12, you know it's another 4. 4 times 4 is 16. So the faster way to do this is to realize 16 goes into 48. So again, you want to just keep trying those numbers on your perfect square list to find the biggest one that goes in. So 16 times 3, square root, 4 square root of 3 then is your final answer. So a lot of people wonder, how do you know if you're done? Well, let's take this one for example. If your final answer was 2 square root of 12, so that's what that answer would have been in that step. If you think that is your final answer, you need to look at this number. The number under the square root sign cannot have a perfect square that goes into it. Well, 4 goes into 12, so that's how you know you are not done. So then you could do this again. 4 and 3, 2, 4 square root of 3. Okay, so you have to always check the number inside the square root. If it has a perfect square that can go into it, then you need to be taking that out, is what we call it. So look on your list on the right-hand side to find the perfect squares that go into that number. Split it apart into 2 separate square roots then, and make sure your final answer usually will have a number on the outside and a number on the inside. Every once in a while, like number 4, you can't find any perfect squares that go in.